Unit circle analysis. Before jumping into graphing sinusoids, let's take a look at where these graphs originate from. The unit circle. We call this the unit circle because it has a radius of 1. Sinusoidal waves can be derived by taking the sine of different points of the unit circle. We first need to express the various angles in a unit circle in terms of pi. To convert degrees to radians, we multiply the angle in degrees by pi over 180. So if we draw a line from the origin to the four main axes in the circle, we get 4 different angles. Drawing a line with an angle of 0 degrees takes us from the origin to the right side of the circle. Converting this to radians gives us 0 radians. Drawing a line with an angle of 90 degrees from the x-axis gives us a straight line pointing up from the origin. Converting this to radians gives us pi over 2. Drawing a line with an angle of 180 degrees takes us from the origin to the left, which then converted to radians gives us pi radians. Finally, drawing a line with angle 270 gives us a line pointing straight down, which comes out to 3 pi over 2 radians. Now that we have our 4 main points of a unit circle, let's look at evaluating sine theta at those points. First, let's think about evaluating sine theta of a regular triangle. Sine theta is equal to opposite over hypotenuse. Now imagine a similar triangle as we shrink the opposite side length all the way down to 0. We can also think of this as shrinking theta down to 0. As we can see, as the opposite side gets very small, basically 0, the hypotenuse is roughly equal to the adjacent side length. In the case of a unit circle, the adjacent side is going to be equal to 1, which means the hypotenuse is also 1. That means in this case, sine of 0 is going to be equal to 0 over 1. While we're at it, let's also find cosine at this angle. Using similar thinking, we know our adjacent length is 1, or the radius of a unit circle. Thus, our hypotenuse must also be 1. This gives us a value of 1 for cos of 0. The same can be done in the opposite direction. As theta approaches 90 degrees, or pi over 2 as we just learned, we see the adjacent side shrink to 0, and the hypotenuse now becomes roughly equal to the opposite side. Applying this to our unit circle, we see that the opposite and hypotenuse sides at pi over 2 must be equal to 1. This time, sine pi over 2 is going to be equal to 1 over 1. We can also find the cosine of this angle, with our adjacent side being equal to 0 and hypotenuse again being 1. This is going to give us 0 over 1, which is 0. Putting all this together, we can then find the corresponding sine values for the remaining points on the unit circle. Filling in what we already know, we can write our values for sine theta and sine pi over 2. Without calculating sine pi and sine 3 pi over 2, can you guess what they might be? Notice that pi is exactly opposite 0 on this unit circle, and 3 pi over 2 is opposite pi over 2. Let's think about our squished triangle again. For the case of sine of pi, this gives us a value of 0 for our opposite side, meaning sine of pi is also 0. For sine 3 pi over 2, our squished triangle gives us an opposite side length equal to the hypotenuse, just like for pi over 2. An important thing to note here is that our hypotenuse is always positive, because our hypotenuse is found through the formula a squared plus b squared equals c squared, where the square takes away the negative sign. Thus, we get an answer for sine 3 pi over 2 of -1. By now we may have noticed a pattern emerge. Let's see if we can use our observations from our sine calculations in combination with our previous calculations of cos of 0 and cos of pi over 2. It appeared that sine was oscillating from 1 to 0 to -1 and back to 0 again. Assuming cosine is following a similar pattern, can you guess what cos of pi and 3 pi over 2 are? If not, that's okay, let's calculate them. Drawing our squished triangle shows us that the opposite side goes to 0. Our hypotenuse is equal to the adjacent side. That means calculating cos of pi will give us -1 over 1, or -1. Drawing another squished triangle at 3 pi over 2, we'll have our adjacent side go to 0, which means cos 3 pi over 2 is 0 over 1, which equals 0.